is an example of how you can use the mole calculation to find some concentrations. So here you have 0.15 molarity of sodium hydroxide. That's the concentration of the solution, and the volume that you have is 125 milliliter. In this problem, you're adding 25 milliliter of water, therefore changing the volume to 150 milliliter. So now you have more diluted solution, but you want to find the exact concentration of that solution. So the first place that you want to go to is finding the moles of sodium hydroxide. So you can simply do that by multiplying the concentration by the volume, moles over liter, by the volume, which should have been liter, but it's given in milliliter, so you have to divide that by 1,000, so it will be actually 0.125. So liter would cancel, and you will be left with mole. When you actually carry out the calculation, you will find that you get 0.01875. So once you do that, you have to divide it by the new volume, which is 150 milliliter. So 0.01875 mole divided by 0.12150 liter. That gives you the new molarity of 0.125. Another way to look at this problem is using C1V1 is equal to C2V2, where you're letting the moles of one equal to moles of the other. So here you have concentration as 0.15 for sodium hydroxide initially. The volume is 0.125 liter. Is equal to C2 is what we're trying to find, and the volume is 0.150. So that gives you the concentration for the volume of 150 milliliter. And you will see that you also get the same answer of 0.125 molarity. The last part is converting the unit to micromolarity. So you should know that in biochemistry you will be using a lot of micromolarity. We also use a lot of nanomolarity and also millimolarity. 1 molarity is equal to 10 to the third millimolarity. 1 molarity is 10 to the sixth micromolarity, and 1 molarity is also 10 to the ninth. And that also applies to the liter. So you already know that 1 liter is equal to 10 to the 3 milliliter. You've used this a lot in SI chemistry. 1 liter is also 10 to the 6th microliter, and 1 liter is 10 to the 9th nanoliter. Okay, so using that information, so we want to go from molarity to micromolarity. So you can use dimensional analysis to do that. So you take 0.125 molarity times by 10 to the 6th. So if you actually write out the dimensional analysis, you know that 1 molarity is equal to 10 to the 6th micromolarity. So molarities cancel, and you can get the answer finally in micromolarity.